Hi there, it's Miss Heaton signing in to talk with you about how we actually use oxidation numbers. What's the point of knowing an oxidation number? Well, chemists care about change. Change happens through chemical reactions. And so what we're going to be looking at is how oxidation numbers changing can tell us whether oxidation has occurred to an atom or whether reduction has occurred to an atom. We'll go through two examples and then that's it. So our first example is H2 combining with Cl2 to make two HCl's. So the first thing you always want to do is identify the oxidation number of each atom. And if you watched the prior screencast, you would know that elements by themselves each have an oxidation number of 0 because they have no exponent. But when they're in compounds, then we use our other rules. Hydrogen will be +1 and chlorine will be -1. And those have to do with rules from the previous screencast. So if you have questions about that, pause, go back to that screencast and make sure you review those rules. So now what we want to do is identify what has happened to each element. Here, the hydrogen went from being 0 to being +1, whereas the chlorine went from being 0 to being -1. And remember, that has to do with electrons being transferred from the hydrogen to the chlorine. So because the oxidation number has become more positive for the hydrogen, it has lost electrons. Remember, loss of electrons is oxidation, gain of electrons is reduction. Or you could remember the oil rig example. Oxidation is loss of electrons, reduction is, is with an I. Reduction is gain. So hydrogen has gone from having 0 to +1. Remember, electrons are negative, so it's becoming more positive. So hydrogen here is the oxidized element because its oxidation number has become more positive. Again, it doesn't always have to be a positive number. It's all about relatively going up or going down. Here, chlorine is being reduced. Its oxidation number is going from 0 to -1, meaning that it has gained electrons because it's become more negative. Again, the more is important. So here, chlorine would be the element reduced. Notice that we don't put H2 or Cl2 or the whole compound, it's just the element itself. We also want to talk about how this is possible. What makes oxidation possible and what makes reduction possible? Well, the oxidizing agent, it's kind of like a travel agent. You know, if you want to go on a trip, the travel agent makes the travel possible. Well, here, the oxidizing agent makes oxidation possible by accepting electrons. And remember, accepting electrons is gaining electrons. So this is the element being reduced is found in the oxidizing agent. So here, the reduced element was chlorine, and it is found in Cl2. This has to be a reactant. You always looked at your reactant side. The reactant that contains the element reduced, and the reactant that contains the element oxidized is the reducing agent. So here, we want to find what makes reduction possible. Well, that'd be the thing that gets oxidized. The thing that got oxidized was hydrogen. So the hydrogen on a reactant side is in the form of H2. Notice that it's kind of paired up so that the oxidized element is found in the reducing agent, the reduced element is found in the oxidizing agent. Okay, why don't you hit pause, try this next example on your own, and then tune back in to see how you did. Okay, so what you should have is that hydrogen is +1 for oxidation state, carbon is -4. This oxygen is alone, so it's 0. This oxygen is in a compound, so it's -2, and there's 2 of them, so the carbon here would have to be +4. Here, oxygen is -2, and hydrogen will be +1. So now we want to identify what is changing oxidation numbers. So it looks like the carbon goes from being -4 to being +4, and the oxygen goes from being 0 to being -2 in 2 different places. So one of those is the element being oxidized, the other is the element being reduced. Remember, the oxidized element is losing electrons, so it's becoming more positive. So let's see. Carbon goes from being -4 to being +4. For that reason, it has lost electrons, so our oxidized element is carbon. On the other hand, oxygen has gone from having an oxidation number of 0 to being -2. It has gained electrons to become a more negative oxidation number. So our reduced element is oxygen. For our reducing agent, remember that's kind of the compound, or it is the compound, the reactant that contains the oxidized element. So that would be CH4, because on the reactant side, carbon is found in CH4. And our oxidizing agent would be the compound that contains the element that's reduced. And so that would be oxygen, which is found in the form of O2. You do not need to include the coefficients at all when you are assigning oxidation numbers or determining what is the reducing agent or the oxidizing agent. Okay, come to class tomorrow with your questions. We will continue to practice this. Happy oxidizing!